Hi everybody, this is Gigi from Kauai Community College. In this video, we will be talking about expected value, and we would learn about expected value after we have learned about probability. It's sort of a fun thing to do after probability, so you can put things together and play some games and um, think about what you could do with probability. Okay, so let's get started. Okay, so expected value. Before we talk about that and what that means, let's think about this spinning wheel game. Okay, suppose that it costs you $1 to play. Okay, so I want you to pause this video right now, look at the spinning wheel, and consider the fact that you have to pay $1 to play. Do you think you can win? Explain. All right, pause and jot down your thinking. Okay, so you probably think about the size of the different colors, right? And the value of how much money each one of those will get you if you land on it. For example, if you land on that purple, it's $10, right? But that's actually a smaller slice than the one that is $0 or $2, right? So, what do you think? Did you think you were going to win or not? Okay. And so anyway, that's and would you play this game if you see this as at a carnival? Okay, so all of these thoughts is related to the concept of what we call expected value, right? And expected value is a mathematical way to use probability to determine what to expect in certain situations over the long run. Okay, now the keyword is over the long run. Okay, so not just like one particular spin that you will be spinning, but if you play the game for a while, what would you expect to win some money? Okay, so use probability to determine what to expect in various situations. Okay, that's the expected value, and that is over the long run. Now, expected value can be thought of a type of average that is weighted by the probabilities. And that's what our thought process was when we were thinking about how much money it will get us, depending on the size of the slice of pie there, right? So, and to find the expected value, you multiply the value of each possible event to its probability, and then you add up the result. Okay, and you can use a table like this or so to keep track of the information because it's more organized and it's easy to see. Okay, so let's go back to our game and find the expected value for our game and think about what that means to us. Okay, so we have the event would be blue, red, purple, green, or yellow, right? Those are the choices, the possible outcomes. And the probability of blue is it's look like a quarter of the circle, so that's 1 out of 4. And the value is $0. So when you multiply 1 over 4 to $0, you get $0, right? And then red looks like it is half of the quarter, and half of a quarter is 1/8, and the value is $1. So 1/8 of a dollar is 12 cents, 12.5 cents actually. Okay, and then the purple also is 1/8, and the value of that is the whopping $10. $10, right? So let's hope we land on purple. So that 1/8 of $10 is $1.25. Okay, and then the green get you $0. So multiply the probability, you get $0. And then the yellow will get you $2, and the probability is 1/4. So 1/4 of $2 is 50 cents. So if we go and add up all these values, we would get more over $1, right? $1.80-something. But remember, it cost us $1 to play, right? So we have to take that into consideration, because before you even spin, you already have to lose $1. So that's minus $1 to $1.87. So then the expected value is, we would say, in the long run, you would expect to get 87 cents per spin, right? And in the long run, what's the long run? You know, like how long is long enough? And that's the question to be considered, right? So for example, let's say if you play, say, 100 times, right? You pay $100 to spin 100 times, you would probably expect to walk away roughly $87. And that's what the expected value is saying, okay? Now, let's think of this scenario here. Suppose you win $5 if you draw a king out of a deck of cards. And if you get a red card that's not a king, then you can win $2. Otherwise, you'll have to pay $1. You lose $1. Okay, so what do you think? Is this going to be a winning game? Is this to your advantage? Okay, pause and do some work. Think about that, and then come back to check your answer. Okay, so event would be king or red and not king, and then everything else, right? And I'm going to put the deck of cards up so you can have a reference. Okay. Probability of getting a king, there are 4 kings. So we would say 4 out of 52. And if you get a king, you are going to get $5. So probability multiplied by the value will get you 38.5 cents. Okay, now what if it's a red card that is not a king? Okay, so what are we looking at? Red card that's not a king. We're looking at those, okay? And there are 12 and 2 rows of 12, that's 24. 24 out of 52 possibilities. So that would be $2 if you get one of those. And when you multiply, you get 92 and 92.3 cents, or $0.923. Okay. Now, if you get anything else, meaning all of those that are not circled on the bottom part of your chart there, that would still be 24 out of 52, and that will lose $1. That will cost you $1 if you get one of those, right? So then you would lose the value of 0.462. So in total, and remember, this is the game where nobody had to pay, right? So the total here would just be your expected value, and it is going to be a positive expected value. So it sounds like it's a winning game for you, okay? And you would expect in the long run 84.5 cents if you were to play with this game with somebody else, right? Now, suppose then instead of losing $1, you're losing $3. Is it still going to be a positive expected value game? Okay, and you should go ahead and play around with a friend or a family member and see how this works, okay? And that's the fun part of learning probability expected value. I will see you in the next video.